So here we are in SQL Server Management Studio, and we're connected to an instance of SQL Server 2014. And what I'm going to do is I'm going to create a new database. And so far this is exactly the same as creating a database in SQL Server 2012 or any earlier version. But one of the things I want to look at here is on the File Groups page here, there's a new option here for memory optimized data file groups. So I'll add one of those and I'll call it memfg, and you'll notice that it's going to contain file stream files. It's not actually file stream in the sense that we've used it previously, but the data for memory optimized data optimized tables is persisted as streams, so it's a file stream file type that gets added to that. If I go back to the general page now, I can add a new database file to this, and the row type is usually rows or log or file stream data. So if I choose file stream data, it automatically figures out, well, the only file group I can put that on is the memfg file group. So we'll call this memdata for this file. And I could go ahead and click OK at this point and create that table. I just want to have a look at the transact SQL. Sorry, create that database. I just want to have a look at the transact SQL that's used to do that. So we'll generate a script, and rather than click OK, we'll go and have a look at the script. And you'll see that there's a whole bunch of options that are the default options when you create a database. But the important point here is the file group clause with contains memory optimized data. And that's the only thing that's different between creating a database that supports memory optimized tables and an ordinary database that you would have created in previous versions of SQL Server. So we'll go ahead and run that script, and that goes off and creates the database. And just to verify, there's the database there, MyDB. And if I have a look at the properties of that database, a couple of the properties that you'll notice here, there's memory allocated to memory optimized objects and memory used by memory optimized objects, and there's a little bit of memory allocated already, and there's some system tables that are stored in memory that are already using up some of the RAM. But that's what we've got going on there. So now that we've got that database in place, I can actually use it to start creating tables and all the things that I would do with a regular database. So one of the things you'll notice when you go to the tables folder in Object Explorer and you go to the new menu, there's a new option for a memory optimized table. And if you click that, there isn't a UI, certainly in this pre-release version. It just generates a script template for you to fill in and go ahead and create the table. And rather than work our way through all of the syntax in that, I'm just going to open up a script that already has some code in it. And the first thing I'm going to do is I'm going to create just a regular table, just what we now call a disk-based table. The same kind of table we've used in versions of SQL Server up to this point, just to make the point that even although the database is created as a database that supports memory optimized objects, it still supports regular SQL Server tables and views and all the things that we're used to using already. It really is just a SQL Server database. So we can create a table there. You'll see the table has two columns. It's got an integer ID, which is the primary with a non-clustered index on it, and it's got a date value, which is just a date time value. So I'm going to create another table that's got exactly the same schema, but this one is memory optimized. And it takes just a second or so longer to actually create that. But if we look at the syntax, you'll notice I've got my primary key. Again, it's non-clustered, but this time I've specified a hash with bucket count. And one of the things that we can do with memory optimized tables is we can use a hash index. In effect, what a hash index does is create a specified number of, call them buckets, just locations that we can store rows in. And in this instance, I've specified a bucket count of 1,000,000 buckets. And what will happen when you start to allocate values to those to that index, the value you want to store is hashed. The result of the hash goes into the bucket that corresponds to that hash value, and if any bucket ends up containing more than one row, they're stored effectively as a linked list. There's a pointer in the first row that points to the second row, to the third row, and so on. So it is a fairly efficient way of spreading data across a number of different storage locations. The other clause that's in here that you won't have seen before is the memory optimized equals on option. So that's the thing that makes this table a memory optimized table. And there's a durability clause as well. Now I've actually just used the default value here, which is schema and data. So what we're saying here is, even although the table itself is in memory when we're using it, all the changes and all the inserts and so on are done in memory, it is actually persisted. It's durable onto the disk, which is why we created the file group in the file earlier on. And it's obviously there so that if the database goes down or if we need to restart the database, then that data is persisted. There is an option to say that your memory optimized table should not be durable. In other words, it isn't ever committed to disk. And that's useful when perhaps you're using a table as a session state table for a website or something like that, where if the server goes down, you can live with losing the temporary data that was in there. So I've now got two tables with exactly the same schema. One is a traditional disk-based table, the other is a memory optimized table. And what I'm going to do is just do a couple of comparisons here. I'm going to insert 500,000 rows, and I'm just going to use a transaction to do that first of all into the disk-based table. And the code that's running here, obviously, we've got an integer counter. We're looping around 500,000 times, and I'm inserting into the table each time we go through the loop the counter value as the ID and just today's date, just for the sake of having some sort of value in there. So we'll loop around. That's going to take a little while to execute. That's it finished now, and it took 21 seconds to insert those 500,000 rows into that table. So let's just verify it has in fact got 500,000 rows in the table. Yes, it has. So okay, 21 seconds to insert 500,000 rows. Let's compare that with exactly the same code to insert 500,000 rows into our memory optimized table. Now the point here is the code is exactly the same. We're using a technique called interop. So in other words, we're using standard transact SQL that we would have used before. The only difference is we're writing to a memory table, and you can see that it's completed in 6 seconds. So it's around about a quarter of the time it took with the disk-based table. So already we're seeing a pretty significant performance improvement, and that's just by changing the table to being a memory optimized table. We haven't made any changes to the client code. The transact SQL we were using before is exactly the same as it was, but we're already getting that memory boost, that performance improvement, because the data is now stored in memory. So again, we'll just, to prove that I'm not cheating, we'll verify, and yep, there's 500,000 rows in there. So we can see that inserts, obviously we get a significant improvement. What happens when I delete rows? Well, let's delete all of the rows in the disk-based table, and off it goes, and it takes a little bit of time because obviously it's got to go in and get them removed from the disk. And if we have a look, yep, 8 seconds it took to do that. And if we remove them from the memory table, well, it's practically instantaneous, 0 seconds to remove them from the memory table. So we're getting that performance improvement on inserts and deletes, and you'd also see that similar performance on updates and so on. So that's great. We're seeing a performance improvement just by changing the definition of the table and using the same transact SQL code to work with it as we've used with regular disk-based tables. But one of the other improvements that are available with SQL Server 2014 is this ability to create native store procedures. Now the way that this all works under the covers, the table, the memory optimized table we created earlier on, actually gets translated into a C struct, and that C struct is then compiled as a DLL. So actually what's happening is we're taking that data structure that is the table, we're generating some C code from that defines the table as a struct, and then we compile that as a DLL, and that DLL is what's in memory, it's loaded into memory, and that's what we interact with. Now we can do a similar technique with store procedures. So in this case I've got a create procedure, and the clause that's different from what we've probably seen before is the native compilation option here. So in other words, what I'm saying is create the store procedure, I've written it in transact SQL, but under the covers when I execute this statement, SQL Server is going to translate that transact SQL to C, and it's then going to compile that C as a DLL. So we end up with a natively compiled machine code DLL that we can call. So it's going to be much faster than interpreting Transact SQL. I've got to specify schema binding if I'm doing this, and I've got to specify the context under which it will execute. So I'm executing it as the owner of the stored procedure. There's a slight change in the syntax here in order to kick off the transaction. I'm using this begin atomic statement and specifying that it's a snapshot transaction. But other than that, the code is exactly the same as the insert that we've just seen happen with Transact SQL. So again, we're looping around 500,000 times and inserting some data into the memory table. So I'll go ahead and run that to create the stored procedure. And now let's see what happens when we use that stored procedure. And if you remember, when we used Transact SQL to insert data into the memory table, it was around 6 seconds that it took to insert 500,000 rows. When I use the natively compiled stored procedure, 0 seconds. It's pretty much instantaneous to go ahead and do that code. So a massive performance improvement by using a combination of in-memory tables and natively compiled stored procedures. And again, just to prove there's nothing up my sleeve, there are 500,000 rows in that table.